Now, like we discussed position versus time graphs, we will discuss here velocity versus time graphs. A velocity versus time graph is going to give us the velocity at any time. For example, if we take someone sitting at a position of plus 2 meters for 2 seconds, then taking 1 second to move to the position of minus 3 meters and then staying there. Let's see how that translates here. Now, when we look at this graph here, this is 0. This is going to be the velocities. Let's say 1 meter per second, 2 meters per second, 3 meters per second, 4 meters per second, minus 1 meter per second, minus 2 meters per second, and so on. And this is 1 second, 2 seconds, 3 seconds, 4 seconds, and so on. Now, what do we have here? The first 2 seconds, the person was at rest. What does it mean? Not moving. Not moving, that's a horizontal line here, at 0. After the 3rd second, was not moving either. So the person is here. Again, it's 0 velocity. The only time the person moved is during this 1 second. Okay, now, in this particular case, they didn't tell us how did the person move. We can guess if he was moving in the positive direction or negative direction, since he went from plus 2 to minus 3. So we would think he was moving in the negative direction. So that we know that it's maybe a negative velocity, but we don't know what it is. So we cannot really draw it in this case. But the key point here, velocity versus time graph, we are going to have to graph the actual velocity. Remember position versus time graphs. Position versus time graphs, they give us the position at any time, and the displacement is just the change in position. Now, if I was to ask you to find the average velocity between time t equal 1 and time t equal 5 seconds. Okay, we'll discuss the slope a little bit later on, but then time t equal 1 second, we said position for 1, it is 2 meters. Time t equal 5 seconds, position is 1 meter. Displacement is, position at 5 seconds. So position of 5 seconds minus position at 1 second, which is going to be 1 meter minus 2 meters, like we calculated before, minus 1 meter. And my average velocity is going to be equal, let me write it in terms of displacement, displacement over Tf minus Ti, which is going to be minus 1 meter over 5 seconds minus 1 second. So it's minus 1 meter over 4 seconds, so it's going to be minus 0.25 meters per second. That's my average velocity. Now, in a velocity versus time plot, like here, we just read the value of the velocity. For example, here, what's the velocity at t equal 2 seconds? 3 meters per second. What's the velocity at t equal 1 second? So that's about 2.5 meters per second. What's the velocity at 4.1 second? 4.1 second is about here, that's 0. What's the velocity at 5 seconds? Minus 2 meters per second. Now, here we know that the person is moving towards the positive direction. Again, here the person is moving towards the positive direction. Again, here the person is moving towards the positive direction. Even though the velocity is getting smaller, my velocity is still positive. Here we have a negative velocity telling me that the object is moving in the negative direction. Let's go back to our moving man. And try to explore velocity versus time graphs. Okay, I'm going to take that off. Okay, I'm going to try to duplicate something similar to what we did earlier. So what I'm going to do is move this guy slowly forward, have him stay at rest for a little bit, and then try to move a little bit back and forth. Okay, so slowly, stay here for a little while, fast, stay here for a little while, slowly. Okay, let's stop here. Okay, now we have both graphs. Okay, I'm change the scale there so we can see both. We are going to rewind and try to follow it through. Okay, now here. Let's look here. He's at rest, moved slowly towards about 4 meters, where he stayed at rest there for a while, and somewhat fast moved to this -1 or 1.5, stayed there for a little while, and then slowly moved towards 4, stayed there for a little bit, and fast moved back to about -2, and then fast moved to about 2, and then fast moved to about 5. Okay, now let's look at the easy parts. When I have a zero, when I have a position that does not change, like here, I should have zero velocity. Zero velocity. Zero velocity. Zero velocity. Zero velocity. Zero velocity. And zero velocity. Now, when am I going to have positive velocity? When the person is moving towards the house. When am I going to have negative velocity? When the person is moving towards the tree. Let's observe that. So back. Okay, moving towards the house, so I have a positive velocity. Now here is at rest, so he's at zero velocity. Now he's going to move towards the tree, so I have a negative velocity. He's at rest. Moving towards the house, this small motion, so it's positive velocity. Small positive velocity. It's a small velocity, so we don't see much there. Okay, he's at rest, and then moving towards the tree, negative. Moving towards the house, that's positive again. And last, moving towards the house, that's again positive. And then at rest, that should be zero. Now, so by looking at the graph here, I can determine the velocity at any instant. But then, in places where I have a negative velocity, I know he's moving towards the tree. When I have a positive velocity, we know he's moving towards the house. Now, this does not tell me that his position is negative. It tells me that he's moving towards the tree. Okay, now let's look back at the position versus time graph. Look when the graph is not steep, then I have a small velocity. When it is steep, I have a bigger velocity. Not steep at all, very small velocity. Steep, large velocity. Steep, large velocity. Less steep, a little less. So the steepness of a position versus time graph gives me an idea of the velocity. Actually, in a position versus time graph, the slope at that point gives you an idea of the velocity. Here I have a positive slope that tells me I have a positive velocity. And then the slope is getting smaller here, the velocity is getting smaller. Slope of 0 meaning no velocity. Negative slope tells me that I have a negative velocity. Okay, one last example here before we interrupt this one. What is the average velocity of a racehorse when it runs full circle 1500 meters in 2 minutes? Average velocity, if you recall, is, let's see, what kind of pen did I choose? Average velocity is displacement over time, and in this case our displacement is 0 since we run full circle. Over whatever time, it does not matter, so my average velocity is 0. Okay, in the next recording, in the next segment, we'll get to talking about acceleration.